Morning guys. So two jobs that we're focusing on this weekend. We need to get the stern gland sorted, and it's been a job that I've been putting off for about 3 years. I haven't looked at it since we bought Brupeg, so I have no idea what condition it's going to be in. So I need to pull it apart and more than likely replace the packing. But if it's okay, I'll probably hold on to it just in case. But yeah, I'll probably start fresh and put new packing and grease and everything in there. The reason why we are doing that is I did a job for a local sailor that sort of turned up, South African guy actually, local South African, other side of the planet. He turned up and asked if I can do some welding, and we did a labour swap. He's going to help me do my stern gland, and I did a little bit of welding, actually on a spanner so that he can repair his stern gland. So that worked out really cool. The guy's name's Walter. He's a neat dude, so you'll see him in a video. So we're going to get in there and get the stern gland fixed up. Also, we are having a go at the crash bulkhead, so I need to understand what sort of condition the crash bulkhead's in. A fellow trawler skipper, Peter off Sea King, you might have seen his big shiny red boat in one of the previous videos. He lent us a little camera. It's a USB camera, so you can put it down into a tank and whatever and actually see, what's going on in that tank. I had to go with it, so we're going to look into the crash bulkhead with that, so we'll get that done today as well. So Walter and I have pulled out the stuffing from the stuffing box. So it's this little, if you haven't ever seen one of these before, this is the first time I've actually pulled one apart. It's essentially a square piece of what looks like cord. I'm assuming it's sort of like a wax soaked cord or something like that, filled with grease. So we're just going to get, they don't look too bad, but we're just going to go and get some new ones from the chandlery and then refit it all back in. So I managed to get some 1/2 inch, well, they call it pump seal or something like that, but it's basically the same stuff by the looks of it. And then I just grabbed some grease just so that just in case, I don't actually know if we need grease, but I grabbed some anyway just in case, and then we can sort of pack it all together.
It's just a short piece like this, and that piece gets mounted onto the tube which comes in. Yeah. Inside that tube is the drive shaft, and then the cutlass bearing in the back. Yeah. And then they get tightened up with two heavy-duty hose clamps. Yeah. At the end of the hose you push in, it's like a bronze fitting, a round one. Yeah. With the thread on it, and the same system like here, and the nut. You put your packing in, right. You tighten it, but this part is loose. Right, okay. You can move it a bit. Right. So it doesn't have here this is fixed. So it doesn't have a bearing at this end, it uses the gearbox. There's no bearing. Right, right. Only the cutlass at the back. Yeah. And then mounted onto we got a flex coupling here, you got a permanent. Big piece of steel. Yeah.
So the stern gland in Brupeg is basically, in a way it's like a compression fitting. It has essentially a wax or Teflon coated, I think it's cotton, or it's basically like a version of rope, but it's like a wax or Teflon impregnated material that essentially wraps around the propeller shaft and then is squeezed with like mechanical, essentially it's two flanges that squeeze together. And what that does is it jams the rope packing, it jams it down onto the shaft and just makes it essentially impossible for the water, etc., to come back up the shaft. Brupeg has a grease-filled shaft, so there is no water that drips out of our shaft. It's a completely sealed, greased shaft. Unlike a yacht, pretty standard for a yacht to have water dripping out of the shaft, a small amount of water to drip out. and that cools the packing down. Brupeg's not like that, where you have a completely grease-filled shaft. So I'll show you the packing, and then I'll show you the actual mechanical compression components. So this is the actual the packing. This is the new packing, but you can see basically it's a completely square piece of rope, if that makes sense. And this one here is Teflon impregnated. I'm sure you can get a few other different variants, but this is a Teflon impregnated with wax. I think it's cotton. So I'll show you the one. So this is the new stuff, and I'll show you the stuff we've just pulled out. So this has been in Brupeg for a while, so you can still see it holds its square shape. It maintains that pretty much throughout the life, I'm imagining. I don't think this is very old, but I don't know how old, so I just replaced it anyway, you know, for the sake of $30. I'm not gonna, you know, risk sinking the boat. So this is the wear surface in here. So this is where the propeller basically wears, and if I come right up close, you can still clearly see make out the actual shape of the strands of cotton. So again, I think this is a relatively new one, but it's not as if this, you know, creates a huge amount of heat or friction, or, you know, kills the actual material fast. So you should get a decent amount of time out of it if you've, you know, got enough lubricant and got enough coolant in case if it's a water cooled version. So I'll show you the mechanical components, and then you'll get an idea as to how it works. So this is Brupeg's shaft assembly. So you can see on the left hand side of the screen there, you can see those big bolts that basically bolts to the gearbox, your propeller shaft, and then you've got where the stern gland sits. So this line that you can see here is actually a grease line, so that fills the shaft with grease. So this, between here and here, is the stern gland. Sorry, between there and there is the stern gland. So inside this piece here is where the shaft packing sits, and then this component here is basically just, for lack of a better word, it's essentially just a tube that slides down inside and squashes the packing. So the packing has nowhere to go because this is stiff enough to hold the shape. The packing has nowhere to go, and it's forced down onto the shaft. So obviously, being a circle, it's forced down, you know, completely evenly and so on. But that's how the shaft basically stops grease, in this case, from coming out. So obviously you can see grease all over the shaft. We've been mucking around with it, but generally that shaft should run pretty clean. When if there's either an excess of grease or the shaft packing needs to be a bit tightened, some version of those two, grease will come out of here and sort of be flung out from centrifugal force. So I do plan to have some sort of shroud around there just to capture the grease, just so I'm not flicking it all through the engine bay. Now I'll show you this. It's a little bit rough at the moment. You see these little grease nipples? Please bear in mind this will be cleaned up, in fact probably replaced. But these little grease nipples here, you can see one leads down to the front end of the shaft, and there's another one that sort of disappears off. That actually goes all the way down to right down to the back end of the boat, under that red fuel pipe. It goes sort of through the hull there, and there's a big solid tube on the outside of the hull where it actually sends grease down to a white metal bearing that's right down by the propeller. So the prop shaft in Brupeg is probably about, it's probably about 8 feet long in total, and there's only one bearing. So it has one bearing right at the end, a white metal bearing down by the rudder, and then it has the stern gland packing here. So the stern gland packing actually holds the rudder central in the shaft, in the stern tube, sorry, and then that whole tube is filled with grease. So it's quite a big tube. It's probably a 6-inch diameter tube, maybe more, maybe 8-inch diameter tube, and then the shaft itself is only a 4-inch shaft, so there is quite a bit of grease in that tube. So there's quite a bit of coolant and also lubricating ability in that tube. Right, so what I wanted to show you is basically how you actually cut the cord that goes inside the stern gland packing. So I think the packing gland material, or whatever you want to call it, I'm going to call it cord for the sake of the video. So Brupeg has 3 wraps around the shaft, and then they're compressed in a mechanical, basically a mechanical press. You obviously have to join, so you can't just wrap this stuff up and then squeeze it in, because it just doesn't work. You're going to have big gaps and all that sort of stuff. So you have to basically do a circle, cut, circle, cut, circle, cut, etc. When you do those cuts, so Brupeg has 3 wraps around the shaft. Other prop shaft designs will maybe have, say, up to 5, 6, depends. Like, you know, it can vary depending on the design of your shaft. So there is no right or wrong. Probably less than 3 I'd be a bit nervous, but 3 is completely fine. Brupeg only has 3, but it's also using 1/2 inch thick cord, so it's got 1.5 inches. When you start doing the 3 wraps, you've got 1.5 inches of essentially seal, so there's heaps of seal there for what we need. And we're also sealing grease, not water, so it's a much thicker molecule, so I'm guessing probably easier to seal than water. So anyway, we'll get into the details. So Brupeg has 3 wraps around the shaft. Now when you have each wrap, you need to have a join in them, and if you have all of those joins in a line, you're going to create a leak. So that's a real easy spot for grease or water or whatever to just start rushing through your stern gland. So you need to basically stagger those joins. So in Brupeg's case, we have the 3 wraps, so we'll start, say the first one might be at say 12 o'clock, the second one will come around to say 4 o'clock, the next one we might do at 7 o'clock, you know, whatever it works out to be, but we basically try and stagger them all the way around so that when you compress everything, there essentially becomes no gap in that whole system. There's something, if there is a gap in the wrap, the other 2 are making up for that, if that makes sense. So when you do the join of the wraps themselves, there's 2 ways that you can do that as well, 2 common ways that you can do that. Brupeg has what's called a square join, so it's where you've got your wrap like this, it's a square profile cord, and then you just cut it square like that, and the join just comes together like that. So it's real simple, it's a little bit agricultural, but it works. This is a commercial boat, they've been doing it like that for years on this boat and without any drama, so we just duplicated exactly what they had originally. Another way to do it, that's actually, I think, probably a better way of doing it, is a 45-degree cut. So you see that, you cut the cord at 45 degrees and you do the corresponding end at the same 45 degrees. And then as they come together, it's a wee bit short, so it's a little bit stiff. As they come together, you can sort of see you've got that 45-degree, you know, slice going on there. So the reason you do it that way is that when you, you do it that way. Sorry. So as you wrap it around, let's see if we can show you, got the cut there, you sort of see the 2 come together like that. So you do it so that as you wrap it around your prop shaft like that, instead of the cut sort of being a vertical thing, it actually heads off on a diagonal across the top, so in that way there it would be a diagonal like that. The reason you do it that way is because when you join that together, when you start compressing them, so when you've got your 3 or 4 wraps around your shaft and you start compressing them up, squashing them this way, that 45 degrees, so if I clamp that back up again, so you can sort of see that 45 degrees there, as I start to squash it that way, it's going to start jamming itself in and completely seal up. Whereas if you have the version that Brupeg has, where it's like a square seal like that, no matter how much sideways force I put on there, it's never going to completely get rid of that gap. So that's not to say that this way doesn't work. It clearly does. It's been done for decades like that on lots and lots of boats. But I personally think that the 45 degree makes more sense from a sealing point of view. So yeah, if you've got a prop shaft that doesn't have a lot of wraps around the prop, I would, having learnt what I've learnt doing the Brupeg one, I would probably go and do the 45 degree cuts. They're a little bit more fiddly, you've got to get measurements right and all that sort of stuff. But yeah, it's just food for thought, depending on how pedantic you want to be about your stern gland. So the other thing you need to factor in is the type of tube that you have and what you're actually sealing out. So in Brupeg's case, we've got a completely grease-filled tube, so there's no water whatsoever inside the stern tube of Brupeg. So there's a white metal bearing and a grease seal down at the prop end, and then there's a stern gland that seals out the grease at the gearbox end. So between the 2 is completely grease-filled, and there's a lot of grease in there. It's I think it's about a 6-inch ID on that stern tube, and then that's about 8 feet long, and the prop's only 4-inch OD, so there's, you know, an inch of grease all the way around that shaft for 8 feet, so it's a huge amount of grease. Brupeg uses that grease for lubrication, but it also uses it for cooling. So that obviously grease carries it out to the stern tube. That stern tube is in the seawater, and the seawater starts cooling that stern tube down and transfers that coolness through into the warm grease. So there's no right or wrong, that's just what they did on this boat for commercial purposes. Yachts generally tend to have a water-filled stern tube, so the cutlass bearing down the back end of your boat is normally it allows water to go through, so you'll see like little lines and things going up the stern tube. That basically lets water go all the way up the stern tube to your stern gland, and you're sealing out. On a yacht, you are generally sealing out water. You're not sealing out like grease and stuff like that. Some yachts have little grease nipples and things like that around that, but most of the time you're just trying to seal out. The bulk of it is water to stop the water coming in and making the boat sink. I would say, yeah, as I say, on yachts, I would probably try and do the 45-degree cut, because water's a smaller molecule than grease, so you're going to be trying to seal out something that can leak easier. In Brupeg's case, it's a bit more agricultural because it's just grease we're sealing. So yeah, hence it is the way it is. So Brupeg has a what's called a crash bulkhead. Basically, it's a void at the very front and very bottom of the boat. And essentially, if we puncture that, it gives us the ability to get home, you know, without any real drama. It doesn't affect anything other than the fact that that tank fills up with water. However, normally these tanks are full of water, or like water soluble oil, engine oil, anything like that. Sometimes they leave them full of like they want to get the weight out of them, so they just fill them up with CO2, something like that, so it doesn't rust. I don't know what Brupeg has been filled of in that tank. However, I know that there is nothing in it. Because there's a drain bung that comes back into our cofferdam for that front void, and when I undid it, nothing came out, so there was no possibly gas in there, I don't know, but there was definitely no liquid of any sort. So I need to find out what's going on. So I have a camera on a stick. I have this 7-meter long camera. It's basically a tiny little lens. See if I can show you. Little wee lens with 4 LEDs around it. It's 7 meters long, it's quite stiff, so I'm going to probably put it on a stick, tape it to a stick or something like that. I'm going to send that in and see what we can actually see. So you can see my computer there, this is me videoing, so I'm just moving the camera around. You can see it going berserk on the screen there. Apparently I'm capturing that as a video, so we'll see if it works. We're up on Brupeg's foredeck. Don't often come up here, don't really need to a lot. So I'll just give you a quick rundown of some of the work we've got to do when we eventually get to it. So you can see that handrail. We've got to bash off the last of this light blue. That was the original colour of the boat. We've got to knock that off with a hammer drill and then go through and sandblast all of that. We've got to sandblast all of this red. So that's all been flappered, and we threw some etch on just to stop it from rusting and being a nightmare. We flappered and etched that grey bit you see all the way around there, the side of the boat. But I don't trust that it's going to stay on there, so we're going to sandblast that and then paint that again. And then you can sort of see these little beams coming down here like that. So there's a few of them around, and this blue beam here, they're all stainless, so we're going to blast all of those as well while we're up here and leave those stainless. That's our anchor locker hatch. Now, one of the things we've got to do, you can see that handrail's all bent and buggered. When the boat was underwater, they tried to pull it up via some ropes sort of wrapped around it, etc. Obviously one of them was right there, bent that handrail in. There was another one right there, bent that one in, and then ripped that one right out. So you can see there's a tarp. I'll just come over the other side, but so you can sort of see a hole in the stainless pipe there on the deck. That's basically a hole where the old handrail used to go in, and it just got ripped out. However, today, also got to bolt down the anchor winch. However, today's job, we are going inside the anchor locker. So let's get in here. This is what the boat was like when we got it. You can sort of see all the barnacles and shit. There's still a few barnacles randomly underneath here. However, down here, this is our anchor locker. It is covered in junk and gear and stuff. We'll get you right down inside. I'll turn you around. So there you go. So this is basically looking forward. You can sort of see there's a pipe going out there on the right hand side of the screen that drains our chain locker. Here's our chain locker. There's 1 metric ton of chain. That was the least that I could buy. It's about 150 meters, I think it was, 200 meters, something like that. I also built a stainless thing. So you can see this big thing here. I knocked that up out of stainless basically to deflect the chain. So when the original anchor winch was much further forward, it was way up there, but it's a long story. The way that they had it set up, it was never actually ever going to work as an anchor winch. So I moved the anchor winch back so we could fit a bigger anchor, but as a result, the chain was going to start falling over top of this big wall here and just drop down onto the ground. Absolutely didn't want that, so created this big deflector thing, and it seems to work really well. We've thrown the chain up and down as fast as we can, and we can't seem to get it to fail. It keeps putting it right where it needs to, so pretty happy with that. Now, what I've got to get to, get rid of some of these big old ropes. So, somewhere down on the floor here, there's a bung. It's been 3 years since I've seen it, so I can't actually remember where it is. Get rid of some of these fenders. I apologise for the dodgy camera work. I'm throwing ropes while I'm videoing. There's some that corner. Ah, there it is. Beauty. Right, this little bung down here. A bit more room. This is going to be our window into this tank. So, we're going to pull that bung off, and then I'm going to stick my little camera down into that tank, and hopefully I'll be able to see what we've got going on. Right, here we go. Going in the hole. I feel like someone doing a colonoscopy. Right, so this is the back wall. Jesus Christ, that's a bit skanky. And there's something I've just hit. See if we can get right through that. I'm randomly guiding this in. I don't know where it's going. So that is the absolute bottom. So that's pretty shit overall. Can't really move the camera around that well. Cool. So I've got a rusty hole in the bottom. Wow. Who knows? Probably should cut a hole in it and just sandblast it out. So I think I'm following the rear of the tank, like the bulkhead. Let me go back down, sorry. See if we can rotate the camera around. How bad is it rust? God, it's pretty hard to tell. Like, it doesn't look good, but so if this tank fails, like let's say worst case scenario, it rusts through. If this tank fails, the fuel, it'll either rust into the fuel tank, one of the front fuel tanks, there's two that backed onto this. It'll either do that and fuel will go spilling into this, or it'll, failing that, it'll rust out into the sea and the tank will fill with seawater slowly. But again, it doesn't really matter because that whole thing is designed as a crash bulkhead, so we can smash into something and rip the front of the boat right open and it still doesn't make any difference in terms of the boat's buoyancy or safety. Yeah, I need to put a stick on this so I can guide it a bit better. So as you can see, it's pretty hard to actually see what sort of condition that tank's in from that little camera. It's just not high resolution enough. It was shooting at 14 frames per second, so if anybody knows cameras, that's pretty low. Most of our stuff that we shoot for these videos is minimum of 30, maximum of about 60. So 14 frames per second is pretty rubbish in terms of resolution. So yeah, what we're going to do is, behind me you can sort of see the front end of the boat, so we're going to essentially cut off the tank, isolate that, but we're actually going to go down from the top, so I'll show you what I mean by that. So this is the crash bulkhead area here. You can sort of see it's slightly hard to see, but about maybe a foot up from the waterline is a weld mark. That's the deck line, and then it sort of comes all the way down here, just behind that little square. You can sort of see there that's been just in front of the anode, and just behind the square there's a double continuous weld all the way down there. So that's the crash bulkhead in this boat. I'll see if I can show you from the front. So they've obviously had a look in there before, so like it's pretty common on these boats. They'll cut things like this, put their head up in there for a survey inspection or whatever, and then just see what sort of condition it's like. The trouble with cutting into this tank, this tank here from the outside is you can only weld it from the outside. You can't physically get inside this tank to weld it. So everywhere else where I've done a weld in the hull, like if you look back here, show you the water tank. So you can see that big square there. I basically was able to cut that hole, sandblast and paint the water tank, and then weld it on both sides. So I climbed inside the water tank and welded it up. And I've done that everywhere where there's a a patch or a panel or whatever on the hull. I've welded it on both sides. But the trouble with this is that you can only do it on one side, so the weld has to be absolutely schmick, or you risk filling the tank with water. So because I don't necessarily have absolute 100% confidence that I'm good enough to weld that outside and get it perfect in one shot, what I'm going to do to minimise the risk, come back here a bit, I'm going to, so you got the deck is about there somewhere, so I'm going to go down into the anchor locker like I just showed you, and then where that little bung is that I undid and put the camera down, I'm pretty much going to cut an inspection hatch in that floor, in that tread plate floor, and then go down into the tank from the top. The reason I'm going to do it that way is that if the weld fails, virtually nothing happens. Like, yes, the tank might fill with water very slowly from a leak or whatever, but like the boat's not going to go through any drama. Whereas if I cut it out here and it fails, then it's going to take a day, and that's going to be full of water. So yeah, so that's why I'm going to minimise risk by doing it from the top inside the boat hull as opposed to cutting through the boat hull. So thanks for watching. Yeah, as you can see, there's quite a lot still to go on the old girl. If you're watching this and you're not subscribed, please click on the link below and subscribe. Absolutely love it when you guys subscribe. It means that we can actually notify you guys when we put out new material. If you enjoyed what you watched, then yeah, we've got heaps more coming up like this. And also I wanted to give a thanks to all of our Patreons. So Patreons help us get this boat in the water faster. And yeah, it's awesome having you guys on board. Really appreciate the support. Thanks very much.